Welcome to my talk, everybody. So I will try to bring you into the security world and about the most effective security measures at scale. We also work with Cloudflare in our company. So TX Group is a large Cloudflare company, but actually we just use it, or mostly use it, for security reasons, not for caching reasons. But it's good to have that talk before about the caching part. I was not aware of that. So, who am I? So my role is Group CISO, so I'm Chief Information Security Officer. So I'm responsible, or more or less, if a company in TX Group is hacked, I'm held accountable for that. So that's what usually, hopefully, does not happen. I'm doing security now for over 20 years, from technical management and all that stuff. So I also worked in different companies, started in banking, ended up in a startup that never left the startup stage, so I know how failing feels like. And being in a garage for a long time, I also was in the telco industry and now in the media industry for a long time. I'm not just doing security, I'm a tech enthusiast, and I'm also co-founder of 42.ch, so just that's about me. And one important thing is that security needs to shift left. There is some call it DevSecOps, others call it AppSec, and shift left is something we called our strategy for product security. We called it shift left, and I'll explain what this really means. Just a few words about TX Group. So what is TX Group? So most people know 20 Minutes in Switzerland, or maybe the Tagi, so Tagesanzeiger and the paid media titles. So that's actually, yes, that's also part of our company. But we have a couple of other companies in there, like in the TX markets. There's Ricardo, Tutti, HomeGate, Car4You, Jobs.ch. We have Doodle for calendar invites. We have Z2 for video streaming. And then even we have a venture capital organization in our company that is doing investments in little banks, mostly fintech companies like Lücke, Neon, and others. So we do a lot more than just printing and news, what most people already know. One that all the companies we have in common is that we are a cloud company. So we are cloud companies, you could say. So we have several cloud companies that belong to us. And cloud company usually means we run like 80% of everything we do, we run on AWS, and the rest, the 20%, we run on Google Cloud Platform. So for example, Ricardo is doing a lot in Google Cloud Platform. They run Kubernetes there. If you go to HomeGate, for example, they run everything with Lambda functions serverless in AWS. If you have our content management system for example, for Tagesanzeiger, that's actually running on virtual EC2 instances. So we have, from a technology stack, we have everything. So what do we do? So the first thing is, for smaller companies, it's usually something that many know, but we implement BeyondCorp. BeyondCorp no one knows, but Google has invented that. It's called a zero trust architecture, but we get rid of the internal network. So our clients, so like my client, my Mac here, if I work at home or in the office, it's the same. I'm outside the network. So our network is just an internet access, meaning that if my device is infected, I can't infect the systems in the internal network, so production systems or other systems. So if you are just a cloud company, that's normal, but many still have the architecture of an internal network with VPN, so we go VPN-less. And what we do is we collect all the log files from our IDP. We use Okta. We collect it from Google Workplace, from the Google Cloud Platform, from AWS, and from the clients with a company called Cybereason. That's an Israeli company doing endpoint detection and response and other fancy stuff. But in the end, we just correlate all that log files and search for suspicious behavior. So it's behavior-based detection that we do there, and then they do their machine learning and magic on that. So everyone can do BeyondCorp. It has been invented by Google in 2011. So if you're interested, just Google for it in Google, then you will find BeyondCorp. it's a fantastic concept in trying to get rid of the risk of malware. So I talk about that because it's one element. The client is one element, especially from the developers. So if you have an infected developer or someone gets access to your developer's client, you are screwed. All the measures you have will fail because the attackers can go through the developer client, commit code, and from there on it will end up in production. So that's why this is an important key element. Like I said, we shift left. Everyone has to celebrate that. So we have, I think, 600 engineers and developers in our company, and we try to bring that to every one of them, that we do security from the beginning on. So not in the end. So if you deploy, let's take Cloudflare, and try to solve all the issues you have with Cloudflare, you will fail. Definitely, you will fail, because you try to build a wall around the mess the developers have created, or the engineers. So you have to rethink that. If they do that from the beginning on in the right way, I wouldn't say you don't need Cloudflare, you still need that, but you don't have to implement it like a web application firewall to prevent intrusions and stuff. So if you have good code, you have less problems. So that's why shifting left solves problems earlier. So what does that mean? This is a very super simplified and not completely correct CICD pipeline extended to the developer itself. So something that you need to do is really, if you go before you really enter the CICD pipeline, you have to train your people. That's a key element. If you have shitty developers, you can't solve it with technology. So what we have is we train developers how to hack. So how to hack websites. If they know that, they also know how to prevent that from happening. So there are good tools available. For example, Secure Code Warriors is something that everyone can try out in small teams where there are competitions between developers and engineers. On our client computers, we deploy EDR. That's some kind of next generation antivirus that's not working hash-based but behavior-based. And it's again, everyone can do that, but it's worth investing in it. Even if you run a Mac, even if you run a Linux, we deploy that everywhere. So there is no difference. There are small other things we do. For example, we deploy YubiKeys almost everywhere. So with the YubiKeys, we enforce the 2FA everywhere where it's possible. And we can store certificates on the YubiKey. So it's something quite fancy to do second factor authentication with that. Now, what we then do is the code that is being committed, we do source code analysis. There are a couple of really good tools out there. So Deep Code is something that we use. It started as a spin-off of the ETH Zurich. It's now acquired by Snyk, but you can run it for free up to 25 developers if you have a team up to that, and they run machine learning against your code to find flaws in your code. So that's again, when the developer is developing, you get the feedback quite fast back to the developer that something is wrong. We use that next to Sonar Cloud. Sonar Cloud is just for code quality, a good tool. It's free for smaller teams and public repositories. If you have closed private repositories, it costs a little bit for line of code. A tool I would look at, so we don't use that yet, is semgrep. That's a completely open source tool invented by Facebook. Now they did a spin-off open source tool for that, and they run a really effective engine against the code. So it's like grepping through your codes in an extremely fast way. That's a tool I would definitely look at. There are commercial solutions out there that cost insane amount of money, but with tools like semgrep, Deep Code, or Sonar Cloud, you can do that in a very low budget way. You have a question right now? You can ask, yeah, that's fine.
Yes. So are these tools language agnostic or that?
Mostly. So TypeScript, JavaScript, Go. So you have a lot of languages that are covered, even Java and other languages. If you go for COBOL or some old-fashioned languages,
for example?
should be covered. For sure for Sonar Cloud, I'm not sure for Deep Code, but they extend that.
Yeah.
Deep Code, for example, also has an IDE extension, so you can have it in your Atom, Visual Studio, or whatever, so the developer directly gets feedback. And that's an important part, because then you don't have to run tests afterwards. It's annoying to get that from your IDE that you write bad code. At a certain point, you will learn to write good code. So this is the training element out of that. Then something that usually happens when hackers get in is outdated libraries. It's a quite simple thing, and it's so easy to solve. So there are tools like, if you go use Golang, you can use an open source tool called Nancy that is checking if outdated libraries are used. You can use npm audit, you can use Snyk. Snyk has a couple of languages that they support without any costs. So checking libraries is a key element, so everything keeps up to date. Then, as soon as you have written the code, you commit the code, and what we do there, we run a couple of tools like TruffleHug, that's for AWS, so that's the truffles, finding the truffles. So this tool finds secrets in the code, so passwords or access keys or these kind of stuff. It's just finding like 70 to 80%, but it's one of the key issues if hackers find somewhere an access code somewhere in a commit, some password. This is the way many hackers get in, and with tools like that you can find that very early. So you should, as a developer, you should use tools like the AWS Secrets Manager. You should never have real passwords somewhere in the code, but actually this is happening quite often, very, very often. What we then do is we usually use signed commits. So with the certificates we have on the YubiKeys, so if a hacker would get access to your repository, this happens quite often, he could not commit any code because he needs a valid certificate for that, for signing that. And you can work with pull requests and all that stuff, but you have to make sure that there is some kind of quality check before the code is really then automatically running through the CICD pipeline. Like with the library checks, there are ways to find outdated libraries directly in the repository. For example, Dependabot is a very cool open source project that checks every library you have. Because maybe if you just do that when you commit, if you just commit, for example, for a small project, let's say 4 times a year, you would only check 4 times a year for an outdated library. Dependabot is checking all the time, so if you have an outdated library, it opens up a pull request, for example, automatically to upgrade that library to a new version. That's a very simple method. It's open source, you just have to use it. There's also RenovateBot as an alternative, or if you are on GitHub, there is GitHub Security Alert, depending on the pricing plan you are on. But Dependabot is a good example, what we, for example, use. Then, if you enter that automatic stage, you have that 2 big parts. So the testing, whatever you do in there, there might be another way you do that. But if you test, there are some key elements what you then can do. Again, you can run these code scans against that. Tools like SemGrep and Deep Code and Sonar Cloud are good, and they make sure that you only can, for example, Sonar Cloud is doing that, you can only go forward if you pass a quality gate. And a quality gate can be that, for example, you have comments done in the correct way, that you also don't find any critical vulnerabilities like cross-site scripting or something else in there. So this is something I would always use, and automate it. Don't do things manually, try to integrate it in your CICD pipeline. Something we don't use are abuse tests. This is more a theoretical thing, but you can run, if, for example, like Netflix is doing that, they take down regions, servers, they, for example, increase latency, but intentionally, and you can run their tests also against your infrastructure or against your code in that testing areas. But this is this is quite advanced, that's why we don't use that. So it's difficult to do that at scale. So that's why we at the moment don't use that. But what we do is we regularly scan our cloud environments. So if we go, for example, to AWS, we use Prowler. That's an open source tool. The C Suite is also open source, but Prowler, it's an open tool on GitHub. If you run Prowler, it will search and audit your whole configuration. So if you have, it checks the IAM rules that no one really understands. If you have a large AWS environment, it gets so confusing. It really helps to find weak spots in there. But also if you have, for example, open S3 buckets, so the whole S3 bucket configuration parts and other parts. If you are running on Google Cloud Platform, they have integrated Forseti. That's also a very good tool to check the Google Cloud Platform configuration. That's also open source. And then you have the results. You have them in the Google Cloud Platform, somewhere in the security command center. There are some things are centralized in the Google Cloud Platform. Both make sure that you check your infrastructure, so that the infrastructure that you have set up, either a Google Cloud platform with the machines, or if you have Kubernetes, doesn't matter, they usually find it quite well. So the base configuration. Then there are additional scans that you can run. One example is Gauntlet or BDD security. Super complicated. You can, for example, try to inject latency somewhere, like the abuse tests. But actually running that at scale means that your team must already have done a lot of other stuff. So it's just that you have seen that somewhere. You can run additional security scans with Gauntlet and BDD security, but I would just go for Prowler or Forseti. This really brings a good result on your cloud infrastructure. And then there are the web application scans. You can either run them against your live system, so your production system, but you can also run them in your CICD pipeline. So actually there are no good open source tools from my point of view. We use Detectify. That's a crowdsourced web application scanner that can just completely run via API. So as soon as you commit new code, it runs through your CICD pipeline. At a certain point, you can trigger the scanning with Detectify. And the difference between, for example, Arachne is an open source scanner. The difference is just that it's a SaaS application. You click and it's really working quite well. And it's enriched with additional findings. So if people, for example, attend bug bounty programs, so I'll explain that later, but if someone is researching vulnerabilities and is earning money with that, he can sell that finding before it's made public to, for example, Detectify, and they integrate it as a test module. So you have the known vulnerabilities in a large database, and additionally you have the unknown vulnerabilities or a couple of crowdsourced found vulnerabilities in there. So we use that like Spotify or Atlassian. They also use that, and they integrate it in the CICD pipeline. We do both. So we have it in the CICD pipeline, but also we run it against production. I would invest a little bit of money to run that. You pay per team, more or less. So small prices, but you get a much result out of it. And then what we also do is we check if you run containers, so either Docker or Kubernetes. We run infrastructure tests against that. There is one, for example, called Kubebench. That's one of the best that we found out. Kubebench is an open source project, so that you can just use it. Like Prowler, if you run Prowler and Kubebench, you more or less know that the base infrastructure is set up correctly. And we run that regularly so that we make sure that things are kept in a healthy state. So if we move forward to more the production view, so if things are there, it gets expensive. So all the steps earlier are not interrupting anything in your website. So if you now do things, it gets really expensive. One thing is the web application firewall. So we run things that natively run on AWS, we usually protect with AWS WAF. So there you have DDoS protection with AWS Shield. On top of that, we have the commercial WAF product to protect us against DDoS attacks, mostly just DDoS attacks. And you could say the other part of our company is using Cloudflare for DDoS protection. We also apply a couple of WAF rules, but if you do a lot of measures that I mentioned before, you usually don't need them. So there should not be any cross-site scripting or SQL injection or whatever in there, because you already found them. So we try to use Cloudflare mostly for DDoS protection. The same for AWS WAF. And it really depends where you have things hosted. Maybe from a pricing perspective, it makes more sense on AWS or on Cloudflare. For both, we use Terraform to deploy our rule set there. So it's something, we don't use the UIs, we just do everything usually with Terraform. Then something, we do audits, that's the boring part. So we have, let's say, one time a year, I come by with, for example, our digital companies, and we test them. So we have manual auditors there. That's the old-fashioned way of doing things. So we tend to move everything to bug bounty programs. So we work together with a platform that's BugCrowd, where we pay researchers if they find something. So if you, for example, go to 20 Minutes as one example, that's running on AWS, Kubernetes. There we have, it's not yet public, but we have a almost public bug bounty program where we have around 800 researchers that search for vulnerabilities. So, and it's a first come, first serve principle. So if a researcher finds a bug in there, it can be rewarded only one time. So it's like a competition between the researchers. And we don't have to care about the payout. That's why we do it via a platform. So in a larger organization, it gets very complicated with finance and controlling. So if you have a researcher reaching out to you that he found something, you can do that by your own. Everyone can run a bug bounty program. The problem is if the researcher then comes from, for example, I don't know, from Iran and is requesting Bitcoin, it gets really complicated from a controlling perspective without an offer to make that working. So if you have them in such a bug bounty platform, you have a wallet and the platform is taking care of the payout. So that's why we work with such companies. It's, for me, one of the best measures. So if you take Detectify as a vulnerability scanner and a bug bounty program and a DDoS protection with things like Cloudflare, that's the most effective way of dealing with security. You should never run a bug bounty program without having other steps done before, because you pay if things come in. And if you have a limited budget, and it can run out really in minutes, but it can also be very sustainable. So, for example, in the beginning of when we started with more than a year ago with 20 Minutes, it was on the day, it was like exploding in the inbox, and I thought, oh my goodness, my budget, I'm getting really nervous. But after now 1 year, we have 1 to 2 findings per month. And that's a good thing because developers get used to treat security as a bug. They use it, they treat it in their tools, and it's easier to look at 1 or 2 bugs per month rather than one time a year or audit with 30 bugs, for example. Then you interrupt everything. So with that, you have that continuously and you distribute that over the year. And if you have a very secure platform at a certain point, you don't pay out anything. So it becomes cheap. The beginning is you get nervous, it's not that cheap, but in the end, it's really one of the best ways of doing that. What we then do is, it's not on that slide, but if we find that, for example, a problem in our login system, we want to make sure that this never happens again, we take that one, give it over to Detectify, and create a module out of it, a testing module. So we do regression tests for security with that, knowing that it's not like normal regression tests are done, but it's a good way to make sure that these things don't come up again. So something that is not easy to implement if you are in a smaller organization, but we collect all the log files that we have. For example, from all the AWS logs end up in CloudTrail, so we collect all of that, and we run that in our SIEM. So it's more or less a security information and event management system. It's just a log system. You can use Splunk or other tools. We have our external vendor who's doing that for us, and he's then finding, for example, if someone is creating an open S3 bucket, it creates an alert. So if you have reached some kind of healthy state and you have all the log files available, you can make sure that it doesn't become unhealthy with that. So you have to create some rules by your own, but if you want to make sure everyone is using 2FA, no one is using an open S3 bucket, and so on and so on. We have a lot of use cases there to make sure that nothing gets unhealthy. That's where you can have super expensive solutions. You can also set everything up with Elasticsearch. So it's not rocket science, it's just a matter of if you have the right people to set things up. What we do, but I also didn't highlight it because it can become also expensive, is a threat intel. So there are companies that look for information in the darknet. So we use digital shadows, but it's, for example, you can grant them access to your code or to you name the GitHub repositories, you name the VIP users, and then they run their searches if it comes up somewhere in the darknet that people plan a operation, so a hacking operation against your organization. So mostly nothing comes up with that, but what we usually find is compromised accounts from users we have, so from employees. So if they get lazy and access a forum with the same username and password, or with their Google account, for example, if you have that one, it can become dangerous. For me as a CISO, it's really complicated if I want to reach out to the users. If it's just a photo forum, it's fine. If it's a dating website, it gets a little bit more complicated. And actually, on a large scale, these kind of things can happen. And it's difficult then to make the user aware, by the way, if you do some dating or stuff, use another account for that. Don't use the same account. So, and actually, these are one of the main reasons hackers get in, because they steal accounts and credentials. So 2FA is one of the simple things to get rid of that problem. Then there's something we already use. These are honey tokens. In the end, it's the idea of having a honeypot. So you make fake websites, and you can also make fake Lambda functions running that are accidentally, they look like someone could access them publicly, and you just look what people then do. So it's quite easy to point people away. Canary tokens is a very cool project doing that in company. They create that kind of honeypots, also based on serverless. And the idea comes really from the mining people. They had canaries with them because they died earlier because of the gas, for example. So they died, and they knew, okay, now we have to run. So that's the idea of the canary tokens. There's a project called Spacecraft to create honey tokens on scale on AWS. So that's a fantastic tool. And then the last thing is what we What we not yet do is, but it's chaos engineering. It's something Netflix has started with the chaos monkeys, so you can randomly kill virtual machines, kill, for example, containers or whole regions, just to make sure that your infrastructure stays resilient. So if you, in the past, if you worked in a bank, these were disaster scenarios. So you did that one time a year, and usually you were able to survive that scenario, but nothing went like expected. And for example, Netflix is just randomly running these killing monkeys, that is killing regions, servers, functions, everything they have in their infrastructure, meaning everything is in such a redundant and resilient way that it can't fail. So that's how that works. So it's a super complicated. You can do a lot of stuff in every step, and you can fall asleep. So I try to simplify it. Things that, from my point of view, are really the best ones. On the left side, it's a deep code or a semgrep, so to scan your code. It's something like Detectify scanning your web application, and tools like DependerBot and SonarCloud to check for outdated stuff. So this is on the one hand what is very successful. On the right side you see Cloudflare. So you have to take care of DDoS protection, because the best code doesn't protect you against DDoS protection. And we had 1 month of DDoS attack. So we were under attack for 32 days, every day, several waves. And the waves were really big. So our infrastructure without DDoS protection would not be able to scale up in such a way. So we had Kubernetes on AWS, but we then fast realized we run out of IP addresses if we don't have any protection in front of that. So there are always some limits that you didn't plan. So things like Cloudflare, others are really good. I would always try to get to bug bounty programs. There you can run that for free if you feel good and you trust your developers, then you can do that. It's something everyone can do, or you go to a vendor. And then I would occasionally also do an audit, even if it's a more boring, old-fashioned way. It's good to have people looking at your what you have built, because you get some kind of blind spots, even if you are not the developer in there. And they all lived happily ever after. So now I'm finished.
Yeah, thank you very much, Andreas, for this talk. Very interesting approach to use bug bounties to attract hackers, and in a good way to make your sites more secure. So I didn't see any questions in the chat, so this would be the last chance to write questions to the chat, or we would then switch over to the next speaker.
So you can earn a lot of money with bug bounty programs. So the best one is running on HackerOne. He earns 2 million a year, more than I earn, honestly.
Okay, 2 million a year from bugs, that's quite amazing. Cool, so still no questions here. So I suggest we move over to the next speaker, Stefan. Thank you very much, Andreas.